All right, we have talked about isosceles triangles already. Today we're talking about equilateral. Equilateral triangles are the same as equiangular. All right, so remember, if the measure of angle A and the measure of angle B and measure of angle C are all equal, then they are equilateral. I'm sorry, equiangular. And then if AB is congruent to BC is congruent to CD, or AC in this case, excuse me, it is equilateral. So angular for angles, equilateral for sides. Remember, we mark that with whooshies for our angles and then our little tick marks for the sides. A triangle that is equilateral then it's also equiangular, all right? And the angles are 60 degrees, not the sides, all right? Not the sides. The sides are not 60 degrees. We measure sides in inches, centimeters, miles, leagues, things like that, right? Angles we measure in degrees, only angles. So we want to find the missing measures, for these triangles. We know that angle A is 60 degrees, angle B is 60 degrees. We can solve for angle C. So we got 60 plus angle C is equal to 180. So we have 120 plus angle C is equal to 180. When we subtract 120 on both sides, we get angle C is equal to 60. So this is also a 60. Well, wait a second. That means that we have all three angles are congruent. That means all three sides are congruent. If it's equiangular, it's also equilateral. So if we know AB is 9 feet, we also know BC, and we know AC. It's 9 feet. So for this one right here, we have been given that side JL is 24 centimeters, and we know that it's congruent to JK and KL. Because we know all three sides are congruent, we also know all three angles are congruent. Well, what could that be? 60 degrees. All right, if it's equiangular, it's equilateral. If it's equilateral, it's equiangular. So because this was equilateral, it was also equiangular. If it helps you to think about it, we know that angle J plus angle K plus angle L will equal 180. And because all three of our sides are equal, all three of our angles will be equal as well. So if we just do x plus x plus x equals 180, so that means we have 3x equals 180. What must x be? X must be 60. All right, so that's why those angles are always 60 for an equilateral triangle or equiangular triangle. All right, for number 3 down here, if triangle PQR is equilateral, mark it if you know it. All right, solve for x and y. All right, solve for x and y. Now, here's the cool thing. If it's equilateral, that means it's equiangular as well. And we know that that means that angle R is going to equal 60 degrees. We also know that it equals 7x minus 3. So we have 60 is equal to 7x minus 3. I can add 3 on both sides. So we get 63. Ooh. Sorry. 63 is equal to 7x. When we divide by 7, we get x is equal to 6. X is equal to 6. So we know our x. Now we need to figure out y. Now we can pick any of these to solve for because any two of them are going to be congruent. I'm going to go with PR is congruent to QR. All right, so that would be, and this is important, this is your setup. So that would be 11y minus 23 is equal to 9y plus 1. I'm going to subtract 9y on both sides. So we get 2y minus 23 equals 1. Then I add 23. So 2y equals 24. When I divide by 2, we get y to 12. So I've solved for my x, it's 6. I've solved for my y, it's 12. Let's take a look at a couple other example problems. So for number 4 up here, we know that angle S is 54. And then we only have 2 of our sides marked. So this takes us back to the isosceles triangles from the other day, right? Where our base angles were congruent. So we know the angle U is 54. and we need to solve for angle T. So that would be 54 plus 54 plus angle T is equal to 180. So that's 108 plus angle T is equal to 180. When I subtract 108, I get 72 is the measure of angle T. For this one right here, again, it's isosceles, not equilateral, but we do know that angle L, our vertex angle, is 28. So we know angle L plus angle M plus angle N is equal to 180. I'm going to call these two X because they are base angles. I know they're congruent. So that means I've got 28 plus X equals 180. I'm going to subtract 28 from both sides. So we get 2X is equal to 152. When I divide by 2, I get X is equal to 76. So both of these angles are 76. All right, you should be able to solve the rest of these. So I'll put them up there on the screen. Take a minute to solve them. Try them out and solve them. All right, and then let's take a look at this one. All right, so triangle ABC is an isosceles triangle. All right, ABC is isosceles. And triangle DBE is an equilateral. So I already know right here that those ones are congruent. We want to find each missing measure. Now, if this is an isosceles triangle, we can already see that AB is going to be congruent to BC, right? Those are our legs that are congruent. That's why I've drawn it the way I have, actually. So we know DB is congruent to BE is congruent to DB. We also have these angles 4, 5, and 6 in here marked off. What do we know about those angles already? If it's an isosceles triangle, ignore all of this, okay? Focus on those. Those angles must measure what? 60 degrees. They must measure 60 degrees. So there they are. They're 60 degrees. So now we need to figure out angles 1, 2, and 3, and then 7, 8, and 9. Now, angle 3 plus angle 4 is going to be a linear pair, and we know angle 4 is 60, so angle 3 plus 60 equals 180. If I subtract 60 on both sides, then I know angle 3 is equal to 120. Now, here's the cool thing. Angle 3 and angle 4 were a linear pair. Angle 6 and angle 8 are also a linear pair. So angle 8 must also be 120 degrees. So we've gotten those two knocked off. Now we just need 1 and 2, and then 7 and 9. Those are the ones that we have left, or 7 and 9. Let's figure out angle A and angle C over here. Because ABC is an isosceles triangle, angle A and angle C are going to be congruent because they are base angles. So that means 4x plus 3 is going to equal 9x minus 47, right? We have to know that already. So I'm going to subtract 4x on both sides. So we get 3 is equal to 5x minus 47. I add 47 on both sides. So I get 50 is equal to 5. When I divide by 5, I know my x is equal to 10. X is equal to 10. So if I want to find this angle, angle A, which is also angle 1, that would be 4 times 10 plus 3. So angle 1 is going to equal 40 plus 3. So angle 1 is going to equal 43. So that's 43. Now here's the cool thing. Because base angles are congruent, we also figured out angle 9. So angle 9 is also 43 degrees. So we are left with figuring out what angle 7 is up here. What could angle 7 be? And angle 2 on this side. So I'm actually going to use exterior angle theorem. So if I look at just this, if I cover up that half, I can see that angle 4 is exterior to this triangle ABD. So angle 4 is going to equal angle 1 plus angle 2. So angle 4 equals angle 1 plus angle 2. So we have angle 4, we said was 60 degrees. Angle 1 we just found was 43, and we're trying to find angle 2. If I subtract angle 3 on both sides, 43 on both sides, then I get 17. So the measure of angle 2 is 17 degrees. Now, interestingly enough, because I have congruent sides on this side, triangle ABD is congruent to triangle CBE. So angle 2 and angle 7 are also going to be congruent. So angle 7 is 17. We're going to learn more about corresponding parts and congruency. So for 11 and 12 right here, make sure you draw a picture. All right, draw a picture. So in this one, it's triangle QRS. So just give yourself a Q, an R, and an S, and then mark it. QR is congruent to RS. QR, RS. Same thing down here. Triangle KLM. Angle K is congruent to angle L. All right, and then you want to figure out what you know. Set it up. All right, set it up. Which angles are congruent for this one? Which sides are congruent? Solve it. Let me know if you need any help. I am happy to help. Email me or Miss Wood anytime.